I'm going to take you through the process of modeling, analysis, and design of a three-story residential building sitting on a beam raft foundation using the software ProtaStructure. I'm going to show you how to import drawings from AutoCAD, how to rename your axis, columns, and beam. I'll also tell you the difference between primary and secondary beam. I will show you how to hinge your beam members, that is, how to release moment and save cost. I'll also show you how to insert wall load, story, and wind load. And finally, I'll tell you the governing principles in reinforced concrete design. I'm Miracle Okeke Richard. Welcome to SamGoz Engineering. And in this channel, I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe. Once you open the ProtaStructure, this is the interface it will take you to. So once you come to this place, you just click on new project. So once you click on new project, I'll write you first of all save it, your project name. I like to save this project with, we are designing a three-story residential building. I like to save it with the name three-story YouTube. No, I'll just save it three story, then three-story YouTube. So I like to save it with three-story YouTube. Then you now come and pick your code, which code you want to design with. So it depends on your country, any country, and you choose the code. But in this project, I'll be using Euro code. Yes, United Kingdom Euro code. This is the code I'll be using. Then once you have taken your code, this is the template. I'll then click on OK. So once you click on OK, you allow it to load. Yeah, if you see it now, it will be loading. So as you'll be waiting for it to load, remember we have done the structural framing of this three-story residential building. So until the link to that video is in this video description, and there we are able to explain everything you need to know about general arrangement drawing, that's positioning of column, beam, and slab, both the governing principles. We are able to explain all of them. So it has opened now. So at this point, what you do now, you come and import that your drawing that you saved in AutoCAD. To import it, you come to building setout, then now come to this external reference drawing. Once you click on it, a dialog box will appear. So you now come to this page that says add DSF. I'll click on this add DSF, then I'll now locate down my drawing. So I saved it on my desktop. Look at it. So look at it. That's why we say that it must be a DSF file. So if you can see what they're seeing here is just only DSF file. So if it's not DSF file, you will not see it here. So look at it, three-story YouTube. So I'll click on it and then click on open. So let me allow it. So look at it. But if you let's go up. If you see you're not seeing anything here, so I'll just check this. So look at it, it's not appearing. Then you can decrease the color intensity or increase it by using here. Okay, first click on choose color. Then you can increase or decrease the color intensity by moving this. So at this point, I've imported this. Then the next thing to do now is to import my axis, that's my grid line and my column. Then I'll come to this page named import. I'll click on it. So at this point, my column, my grid line, I used it as I set it with grid line. Why? This is why I say that I should create a grid line layer in AutoCAD. So then my column, I set it as grid line, so as column Y. So I'll come and click on this. I'll check for column Y. This is it. I'll click on it. Then I'll check it. Make sure that none other is being checked. I'll click on OK. So look at it, I'm having as column Y. Then I'll now come over to this point and then click on import. It will not import. Remember, we have the architectural CAD file of this three-story residential building in our seller store, so you can go there and purchase it. So you practice on your own. Practice makes perfect, and the more you practice, the more you get to learn. So click on close. Then I'll also come here and then click on OK. So if you see, you have everything has been imported. These are column, and these are axis, the axis I'll use. But once you look, this axis is not being numbered well. Look at it, A9, A8, A9, A10. It's not being numbered well. So I will rename this axis. You can only do this if you are using ProtaStructure 2025 and above. Yes, if not, you do it manually. So I'll just come to this this review. I'll come to review, click on a label member. I'll click on it. Then I'll just click on this my axis. I'll then come over to this point and change it to this, then click on OK. So look at it now, everything 1 2 3 4, yeah, it has been numbered well. So at this point, next thing to do now is to place my beams, because my columns have already been placed. So next thing is to place my beam. So I'll come over to this point, modeling. This is my beam. I'll click on beam. So click on normal beam. A dialog box will appear here. So once this dialog box appear, what is the width, what is the breadth of my beam? I would like to use the breadth of 225. Reason is because my column size is 225 by 225 and my block wall is also 225 by 225. So that's why I'm using 225 column. Yeah, but I don't say it's a must. Once it gets to all this high-rise building, the breadth can change. Yes. Then what is my column depth? The column depth I'll be using in this structure is 4 feet 460. Remember, the minimum column depth that you can use is 300. That's the minimum. Remember, economy, safety and economy is our priority. So I'll first of all go with the minimum because of safety, which is 300. Then if it fails during design, I can now increase it. But if it doesn't fail, that means it's okay. So I'll go with the minimum, which is 300. But don't forget, we have 300 then plus the slab, because this we will place a slab on top of the beam. Yeah, so that's the slab depth is what 150. So it can be 300 plus 150 is what 450. So that's why we are using a column depth of 450. Then if it fails, then we'll not increase the depth. So with this now, what I'll do now is that I'll come over to this point. I'll input my beam. So I'll array it. So look at it. I'll also come to this point and input my beam. Then I'll input my beam here, and I'll also zoom out and come to this point and input my beam. So I'll escape. Then I'll want to input beam from this point to, I'm having it to this point. Then I'll escape. I'll also input beam from this to this, then from this to this, and then from this to this. I would like to explain something. Let me do from this to this. Let me place it here. So if I press it, you are seeing this triangular sign. This triangular sign means that this beam is a cantilever. Yes, but this beam is not a cantilever. I'm not designing this beam as a cantilever. So what I'll do is that I'll click on this thing, I'll right click and delete it And first of all, I'll double click on this thing again to bring out its property. I'll double click on it to bring out its property. So look at this property. I'll now move this beam from this point to this point. Yes, then I'll now come and do from here to here. Yes, so this is what I'm having. So at this point, this beam now is a primary beam. This one now is a primary beam. Why this is a secondary beam? Because this beam now is being held by two columns. That's this column and this column. So it is a primary beam. And this beam now is a secondary beam because it is resting on this beam. Not just that it is a secondary beam, it's also acting as a point load to this beam, because once the slab transfer its load to it, it will now transfer it to this beam at this point. So it now be serving as a point load to this beam, not just that it is a primary beam. So I'll still continue with my beam placement. I'll have my beam to run like this, and also have my beam to run like this, and also run like this, and also run like this. Then I'll escape again. I'll have my beam to run from here to this point, then from to this point. Then I'll have it to run from this point. Then I'll also be having this. Yes, I can escape again. I'm having it to move from here to here. Then I'll also escape again, move from here to here, escape again from this point to this point, escape again from here to here. Yeah, we are just following the lines that we did in AutoCAD. Yes, that's why structural framing in AutoCAD is very important, so that once you come to ProtaStructure, you don't really waste time. Some people will come and start creating axes in ProtaStructure. Those people, they are just wasting their time, or they are not. So I don't know whether they are wasting their time, but for me, I'll advise you do your structural framing in AutoCAD instead of coming here to create your axis. Yes, I will escape and then place this column from this point to this point. I will escape from here to this point. I will also escape then from here to here. I will also escape then from here to here. I will also escape. So I think, have we placed our beam all around? Yeah, so I think we have placed our beams. So I'll come and close this dialog box. So next thing to do now is to input our slabs. Yes, we have to input our slabs. So what I'll do now is that I'll come over to modeling again, to modeling. So this is my slab. I'll click on my slab. Then they're asking me whether that I should define load case. So I'll click on OK. Yeah, that I want to define load case. So I'll come here and click on load generator. So once I click on load generator, everything here, look at it, everything here, this is for the vertical load combination. All these things, they are all from the code. They are from Euro code. So you just read them at default. Then I'll come over to this horizontal load. Coming over to this horizontal load, this wind load, I'll check it, because once your building is more than 10 meter, the height of your building, once it's more than 10 meter, that means it will be affected by wind. And two, we are designing a 3-story residential building, and two, the height of each floor is 3 meter, 3 meter, 3 meter. So let's go to AutoCAD and check our section, so to know whether what we're having is it more than 3 meter. So okay, look at it. Let's dimension, since they did not give us the dimension. So we're having from this point to this point. So we're having, look at it, 12.7 12.736. So if you see the height of this building is more than 10 meters, that means it will be affected by wind. So we will include wind load in our design. So that's why I'll come here and check wind load, because this building will be affected by wind. So as I've done this, then leave everything, then click on OK, then look at it. They have generated my load combinations for me. So I'll just come to this place and then click on OK. So at this point, this dialog box will appear. So what should I have as the depth of my slab? I would like to go with depth of 150. Yeah, depth of 150. So this is depth of 150. Leave it at type 1. Yeah, because this is a solid slab, so leave it at type 1. Then I'll come over to my loading. So this one is the self weight of your slab, so it has been calculated automatically. Self weight is gotten by the unit weight of concrete times the depth of your slab. Now I'll now come over to dead load. What should I have? What is my dead load? Dead load is gotten from two things, which is partition load plus finishes. Yes, partition load plus finishes. So partition load ranges from 0 to 0.5, while finishes ranges from 1 to 1.5. Do you understand? Partition load ranges from 0 to 0.5, while finishes ranges from 1 to 1.5. Finishes is all this tie or in fact your German floor in general. So I would like to be using the finishing load of 1 and a partition load of 0.5. Yeah, so that means 1 plus 0.5 will give me 1.5. So my dead load will be 1.5. Then I'll now have my imposed load. I'll just right click. This is a residential domestic building, so I'll click on this general domestic use, which is this. I'll not input roof load because this is not a roof slab. It's a normal slab where people will be on. This is not at the roof level. At the roof level we have aluminium to cover our roof, so we are not having roof slab here. So I'll leave this roof road. Then coming to snow, this is African country, so there's no snow road here. And two, coming to lane load, we are not having adverse weather, so I'll not really include this lane load. So at this point, what I'll do now is I'll come and start inputting my slab. So I'll click on it. I'll also click. I'll also click. I'll also click. I'll also click. I'll click. I'll click. I'll click. I'll click. I'll click. Then I'll move. I'll click. I'll input slab, I'll input slab, I'll input slab. Remember, here is our staircase, so we will not input slab at this point. So after this, I'll just come and close this. Then next thing to do now is to hinge our members. Yes, hinge our members. Reason for hinging your members is mainly to save cost. Yes, remember I told you safety. Sorry, I said that safety is our priority. Then after safety, next thing is economy. If you do not hinge your member, that means your ProtaStructure will be providing more reinforcements on your members. Okay, let me explain. You know that summation. Okay, let me just explain this now. I'll explain using this beam. So for example, summation of moment. Okay, if I want to draw the bending moment diagram of this, look at it. It will go like this. From this point, it will go up like this. It will come down, go up because of this hugging moment, come down because of sagging moment, then terminate at this. Yes, so if you see now, it started from here because this is because the moment at this point is 0. Yes, that is the reason why we should hinge here, because if you do not hinge here, ProtaStructure will not know that the moment here is 0. Yes, and it will design, and to if it doesn't, if yeah, it will not know that the moment here is 0, and to it will design to counter the moment at this point, because you not tell it that the moment at this point is 0. So in process of design to counter the moment, what it means is that it will be providing more reinforcement at this point. Yeah, because of there is high moment, because you're not saying that the moment at this point is 0. Yes, if you can remember, summation of moment at any point is equal to 0. Yes, summation of moment at any point is equal to 0. That means the summation of moment here is equal to 0. Look at what I said, summation of moment. I did not say moment at a point. I said the summation. There is a moment here. Maybe the moment here is 30. That means the moment here that we will not be negative 30. If you not do 30 plus negative 30, you'll be having 0. So that is what I mean by summation of moment is equal to 0. So here I'm having negative 30, assuming, and here I'm having positive 30. So negative 30 plus 30, I'll not be having 0. So that is summation of moment at any point is equal to 0. So at this point, let me say I'm having 20 here. So I'm having 20. So you see, there is no moment at this. There is no moment here. There is no beam here. So there is no moment here. So that means what it means is that for summation of moment here to be equal to 0, that means the moment in this beam is equal to 0. So that's why you should tell ProtaStructure that here that the moment at this point is 0. So how will ProtaStructure know that? Is by you hinging it. And if you do not hinge it, ProtaStructure will design to counter that moment. For example, we're having, okay, for example, look at it. Our bending moment diagram will go like this to this point, abi it will go like this upward. So the reason why we do provide reinforcement is to counter this moment at this bottom part. That's why we provide reinforcement. So if you not tell ProtaStructure that moment here is not zero, it will provide reinforcement to counter that moment, and in that case you are no longer economical in your design. You are now wasting your client's money. So please make sure you hinge your beam at any time. Whenever you are doing your design, hinge your beam. So remember, if you are to hinge beam, we are going to hinge here and hinge here. We are not hinging here because summation of moment here is not equal to 0. We are not also hinging here because this is a continuous beam. So moment here is not 0, moment here is 0. Here we'll be having something like this. It will come down and go up again, come down. We're having hugging moment here, hugging moment here. So what I'll do is that I'll first of all, this one, both here and here will be 0 because this is a simply supported beam. So I'll hinge here and also hinge here. So what I'll do now is that I'll first of all hinge all the simply supported, because once it comes to simply supported, you'll be hinging both in IN, this is IN, and both in JN, this is JN. So I'll select all my simply supported beam and hinge both in I and JN. So this is a simply supported beam, and also this is a simply supported beam. Yes, this is also a simply supported beam, and this is also a simply supported beam. Okay, let's do the horizontal first. So this is a simply supported beam, and these two, yeah, we are doing for the horizontals. Yeah, then I'm having a shake again. This is not a simple, this is not, no, it's not a simply supported. I'm having this as a simply supported beam. This is not a simply supported beam. I'm having this as a simply supported beam. This is not, and I'm also having this as a simply supported beam. Yes, I'm also having this. Coming to this one, this vertical, yes, horizontally supported, simply supported. This is also a simply supported beam. Yeah, but it's having a point root acting on it at this point. So this is a simply supported beam. This is not a simply supported beam, and this is not a simply supported beam. This is not a simply supported beam. This is not a simply supported beam. Yeah, this is a simply supported beam. Yes, this is not a simply supported beam, and this is a simply supported beam, and also this is also a simply supported beam. So I think we have done all the simply supported. So I'll right click, then come to this bottom part that say update beam end condition. I'll now say both end hinge. So I'll now hinge both ends. So I'll click on this. I'll now click on apply to the selected beam. Click on it. So if you check now, let's escape. And if you check now, look at it. This thing means hinge. That means there is no moment at this point again. So ProtaStructure will not design to counter the moment. It will not design to counter any moment here again because there's no moment here again. That means here will be normal bar. It will provide normal reinforcement for here. We will be able to save cost by doing this. So at this point again, next thing is that I would like to hinge the ones of IN. Remember, since if I'm hinging the one of IN again, I will not select this simply supported again. I will not select them again. So I want to hinge the ones of IN. So I'll click on this. So I'll hinge this IN. Let's do for this side first. So I'll not hinge, this is still IM, but I'll not hinge this again because I've already done it both ends. Yeah, because I've already done it for both ends. So if you hinge it again as I end, that means the one at this side will just go. So I'm having I end here. I'll also hold my control key and click on this I end. Yes, this is simple. I'm also having an I end here. This is simply supported. I'm also having I end here. Then coming over to this side, simply supported. I'm having I end here. Let me click it. I'm having I end here. Yes, this is it. I'm also having I end here. This is it. I think my I end has finished. Then coming over to the vertical, this is it. I'm having I end at this point. This is simply supported. I'm having I end at this point. Then I'm also having I end at this point. I'm also having I end at this point. Then this is a continuous beam. I'm having I end at this point. This is a continuous beam. I'm having I end at this point. This is a simply supported. So I'll right click to update beam end condition. Look at it at hinge at left end. That's I end. I'll click on it, apply to the selected beam. So next thing now is to hinge the J ends. So let me do for this side first. This is my J end. So I'll click on it. I'll hinge here. So this is another J end. I'll hinge here. This is a simply supported. This is a simply supported. I think we are through with this now. Yeah, I'll come over to this point. This is a J end. I'll hinge here. Simply supported. Okay, this is a J end. I'll hinge here. And also this is a J end. I'll hinge here. And also this is simply supported, this is simply supported, and this is a J and I'll hinge here. So we are done. We are through with all our horizontal, 7 goes over to vertical. So I'm having this is a JN, so I'll hinge here. Hold your control key. So this is a simply supported. This is also a JN, I'll hinge here. Yes, yes. This is a simply supported beam. This one I'll hinge here because it's a JN. I'll also hinge here, JN. Then I'll come and hinge here. It is a JN. I'll also hinge here. Is a JN. I'll hinge here is a JN. And this is a simply supported. So I'll right click. I will right click to hinge all my JN. Look at it, update in beam end condition. I'll now say hinge. I'll now click on apply to the selected beam. So at this point, next thing to do is to input our wall load. If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you. In inputting wall load, so let me escape. In inputting wall load, I want to input wall load. So I'll click on this beam, I'll right click, then click on this, where is it? Edit load. I'll come and click on edit load. So you click on it. Now I'll come and click on wall load. I'll click on wall load because I want to apply wall. So once I click on wall load, this dialog box will appear. Yes, so this dialog box will appear. So I'll come over to this point and then select user define. Yes, user define wall load. Then I'll come. If you want to input doors and windows, you now use edit openings, but I don't want to input them. I want to design the as worst case. So I'll click on this. What is the wall unit weight? Wall unit weight. So once it comes to wall unit weight, you know we are using block wall of 225. That's 9 inches. So the unit weight of 9 inches block wall is 2.87. Yeah, that's the unit weight of 9 inches block wall. 2.87 kilo Newton per meter square. Then, but you know that once after placing that block wall, we'll plaster it. Yeah, that's sand and cement. That's mortar. We'll apply mortar to it. So we'll apply mortar both at the front and both at the end. And two, the unit weight of mortar is 0.3. Yeah, the unit weight of mortar 0.3. But we're going to apply mortar both at the front and also both at the back. So that means we are applying mortar twice. So that means we'll be having 0.3 plus 0.3. Therefore, the total unit weight will now be 0.3 plus 0.3 plus 2.87. That's the unit weight of the block wall. That means the total unit weight we'll be having is that if you do 0.6, that's 0.3 plus 0.3 plus 2.87, you'll be having 3.47. Yeah, 3.47. If you press it in your calculator, you'll be having 3.47. So this is the unit weight of our block wall. Then we'll come over. What is the height of our the height of our block wall? So if you come here, you see what H stands for. H stands for from the top of your slab to your beam depth, like below your beam. That's H. From the top of your slab to where your beam stopped. So the height of the story is 3 meters. Then you subtract your beam depth. You know, your beam depth here is now 300. Yeah, because after your slab, 450, 150 is slab, then 300 is now your drop down beam. So you now do that 3,000, that's 3 meters minus 300, that's 3,000 millimeter minus by 300 millimeter. The 300 is your drop down beam, which is this. So if you do it, you'll not be having 2.7. That's 2,700. Since this is in millimeter, we're using 2,700 because this is in millimeter. Yes, I hope you understand. Look at it. This H is from this H start and HN is from our slab to where our beam stopped, and our story height is 3 meters. So if you now do 3 meters minus by your beam depth, you now be having what? 2,700. So let's click on this one. If you see, that's our drop down beam. That's this D. Look at it. This start, our drop down beam is 300. Why our the remaining part from drop down beam to the floor is 2,700. So if you now do 2,700 plus 300, you now be having 3,000. So what is our block thickness? Is 225. That's the block thickness. That's the block thickness we are using. So don't click on insert. Just come over to this point and click on this. Click on this. So the load has been applied. You now click on OK. So look at it. This is what we're having now. See, we have successfully applied this load. So what I will do now is that I'll copy this load. I'll click on it. I click on copy load. I'll copy load. Then I'll click on OK. Then I'll now apply it to all these beams. So I'll first of all come to this part. This is okay. Since I've copied, I'll come. Where is my beam? So this is my beam. So look at it. This is our beam 1. If you can see it, this is our beam 1. So I'll apply the load from here to, I'll hold my shift key to this point. Yes, let's wait for them to be selected. So if you see it's been selected, look at it from this. Remember, we have already applied it at beam 1, so there's no need of applying it again at beam 1. So from this point to this point. So these are our whole beam. I'll then you either click on paste load You either click on paste load here, or you right click and then click on paste load, any of them. So I've successfully placed my beam load. But if you can remember, we are not having wall at all points. Yes, we are not having wall at all points. So let's go to architectural plan and know the places we are not having walls and the places we are having walls. So coming over to architectural plan. So these are architectural plan. So we'll come over to this point to know the places where we are having walls and the places where we are not having walls. Okay, we are not having wall here. Yeah, there's no wall here, but I can decide to leave it any of them. Okay, in fact, we are even having wall all around. Yes, the only place I know that we are not having wall is just here. Yeah, this veranda. Yeah, this is no, there is no wall here, and also there is no wall here. But we can decide to leave it for worst condition, or you can decide to apply it. Yes, but let's just apply it. But you can decide to leave it here, but let's just apply it. So we'll come over to ProtaStructure. That means, hey, okay, that means we need to start creating a new grid line. Since because we not import that grid line from AutoCAD, we need to start creating a new grid line. So okay, let me just leave it. Let me just design as the worst condition. But on your own, you can decide to offset this grid line, then remove the load. Yeah, you can decide to offset this grid line, and then you now delete this wall load and apply wall load to only the place where wall load is being acted upon. But I just want to leave it like this and design against worst condition. So let me come over to my 3D view and see what I have done so far. So this is my view. I will right click, then click on 3D physical model. So I'll click on it. Look at it, it's loading. Remember, you can get the architectural CAD file of this and practice on your own. Yes, they get the architectural CAD file and practice on your own, because practice makes perfect. So this is what we are having. This is what we are having. This is what we are having. So right now, next thing that we'll be doing now is to go and insert story. You know, this is a this is a 3 floor building. Yeah. So this is the first floor. We'll still insert 2 more floors. So next thing to do now is to what? Insert story. So I'll come over to my plan view. Once I come over to my plan view, I'll then come over to my building setout. Come over to building setout, then come over to story, then click on story, then click on insert story. So once I click on insert story, what is number of story I want to insert? 4. Don't worry, it's 4. You know we are designing for a 3-story residential building. So if I design 3-story, you insert 4. If you are designing for 5, you insert 6. So I'll then click on generate member from the selected story, and then the selected story is the story 1. Then I'll now say the story height should be 3000 millimeter. I'll then click on OK. So I'll allow it to generate story. So look at it, it's generating. Yeah, so this is what I have now. So let's come over to our 3D view. So come over to our 3D view, look at it. This is our first floor, second floor, and third floor. Then this is our roof beam. So look at it. ProtaStructure takes it that this is your story 1, story 2, story 3, and story 4. But we are taking this story 4 as our roof beam. So I'll come to our plan. So make sure you are in story 4. We are in story 4. So if you are looking at this, we don't need all this wall load in this story 4. So I'll come over to story 4, click on this triangle here, then come to my beam. Once I come to my beam, I'll select from this one and go to my this beam, hold my shift key, click on this, then I'll right click. Once I right click, a dialog box will appear. So let's wait for it. You now click on delete load, click on it, then click on OK. So look at it, our load has been deleted. Then next thing now, at this story 4, we don't need slab. We don't need this slab. We don't need all this slab because this is our roof level. Yeah, we don't need slab. So I'll come over to slab. Where am I having slab? So this is my slab. I'll click on this first slab. Okay, click on this first slab. Hold my shift key. Then click on the last slab. Everything has been selected. I'll then right click again, click on delete, and then click on see. It's only slab that is being selected. Then click on OK. So everything will be deleted. So this is what I'm having now. But if you can remember, the depth of this our beam is 450. Yeah, the depth of this our beam is 450. But I told you the minimum beam depth is what? 300. The reason why we used 450 here is because of the depth of the slab. Yes, because of slab depth. Remember, minimum beam depth 300 plus slab depth 150. If you add both of them, you'll not be having 450. But now there is no longer slab on top of this building. We are not having slab again on this building. So that means this 450 we are having here, we have to convert it back to 300, which is the minimum beam depth. Then if it fails, we now increase the beam depth, but we'll take it back to 300. So I'll come over to my beam and stay under story 4. I'll come to my beam. Once you come to your beam, look, this is this. I will just then like click. Once I click, I'll now click on RC beam table. RC, that's the first concrete beam table. I'll click on it. Once I click on it, this dialog box will appear. So this is my breadth, which is 225 by 225. Then coming to this depth, which is H, I'll now change it to 300. I'll then come and click on this pencil icon, then change it to 300. Then I'll change it to 300, which is 300. So this is 300. I'll then click on OK. So if you see now, it has been converted to 300. I'll then click on close. Yes, look at it. If you see, is no longer the same depth with this. Look at it. Are you seeing the difference? Look at this and this. You see the difference. So right now we have successfully converted this to 300. So next thing that we'll be doing now is we want to apply our roof load. Yeah, remember we'll be using parapet in this building. This building will be having parapet. We'll be having parapet around this roof for beauty. So we'll be applying our parapet load. So in applying that parapet load, I'll come over to my plan view. So I would like to use slab, cantilever slab as my parapet. Yes, I like to use cantilever slab as my parapet. So I'll come over to modeling, come over to slab. Then I'll pick, some people will use wall load. So you can use wall load, you can use, but me, I want to use parapet, I want to use slab, this cantilever slab. So cantilever stands for this number 12. I'll click on number 12. Then what should be my depth? I would like to leave it as this 120. I would like to leave it at 120. Then so what should be the length of my cantilever? I'm using 400. Yeah, I'm using 400 as the length of my cantilever. Then once I have this now, I'll come over to this point. I would like to apply cantilever from here to here. Yes, I also like to have cantilever from here to here. This is what I'm having. This is what I'm using as my parapet load. Yes, from here to here. I'll just do it around this building. Then from here to here. Then from here to here. And also from this point to this point. I'll take it out from this point. Okay, let me just do it column by column. Then let's wait for it. Let's wait for it. From here to here. Let's wait for it. Also from this point to this point. Let's bring it down. Then from here to here. Let's bring it out from this point to this point. Let's bring it out. Then this is what we are still having. Let's wait for it. Let's wait for it. Let's wait for it. Then we're having from here to here. Remember, you can get the CAD file of this architectural plan and then practice on your own, because practice makes what perfect. Practice makes what perfect. The more you get this, the more you do this, the more it becomes what part of you. Yeah, we all learn by practicing. Yes, the more you do, the more you become password. The more you do, the more it become part of you. So get the CAD file and practice on your own, because it will really help you. So I'll take it out. This I'll do from here to. So let me stop here. Yeah, from here to here, I'm having this. I'll do also from here to here, I'm having this. I'll also do from this point to this point, I'm having this. Yes, and also from here to here, I'm having this. And then from this point to this point, I'm having this. So this is what I'm having, and I've applied my parapet load. Then next thing you do that, you can come and delete some of this beam, because this is the last floor. This is the last floor. And two, we'll be having our trusses running across this beam. So any beam that you feel that is not really necessary, you can delete it. Yeah, to save cost. Any beam that you feel that is not really necessary, you can delete it. But my own, I don't think I'll be deleting any. I'll just leave it like this. So right now we have applied our parapet load. So let's go over to our 3D view. So this is what we're having now. This is what we're having. Okay, let me turn off everything. I'll come to display, come to layer, come to turn off axis, turn off ghost axis, turn off print definition, and turn off my text. So this is what I'm having right now. So if you can see, this is what I'm having. So we have successfully modeled this. Yeah, we are through with our modeling. We have successfully modeled this with our parapet load. Yes, look at our parapet load. We have our parapet load intact. Next thing is to edit story. I'll come over and edit story. You see what I mean by edit story. Come over to this point. Come over to my story. Come over to this point. Then click on edit story. Look at it. Edit story. Yeah, you see what we are going to do there. So in terms of edit story, in case none of them is in its correct height, look at it. This is 3,000, 3,000, 3,000, 3,000. So it's okay. This one is the height. From here is 3,000. This is 6,000, 9,000, 12 meters. So if you can see, we're having 12 meters. So our story height is above 10 meters. That means we must apply wind load. This is just the bearing. So once it comes to this load, imposed load reduction, this imposed load reduction is about high-rise building. It's mainly about high-rise building. So if you want to apply it, we apply it from this point, but it's not applicable in this video, because this is just a 3-story building. It's all this story, like let me say 8, 9, 10 and above. You can apply this load reduction, because not all the time that all the floors will be in use. That's why we do apply this load reduction. So coming over to this point, so what will be our foundation depth? Since we are going with beam raft foundation, we'll be using the foundation depth of 100. So 1 meter. Yeah, 1 meter. Then if it fails, we will not increase, because we are going for beam raft foundation. Then what is our first story bottom level? First story bottom level is 450. Yeah, 450. Look at it. Once you click on 450, you see. Okay, yeah, it will be 450. See, the story height has been increased. Look at it, has been added to this 450. What do you mean by first story bottom level? Like the difference between your ground soil and your finished floor level. The difference between your ground soil and your finished floor level. Then after applying all this setting, I'll then come over and click on what? Okay. Then now say this and the previous process will not be undone. I'll click on yes. So I've applied this. Then after this, I'll now come over to my plan view. So I'll turn back everything, turn back my axis, my ghost axis, my plane definition, and also my text. So everything has been turned on. I would like to come over to story one. Next thing we'll be doing now is to carry out our building model check. So to carry out our building model check, we'll come to this tab, review. Then under review, we'll click on building model check. Then once we come to this place, we'll click on start. So let's allow it. Yes. Okay, that means we're having some errors. If you can see, yeah, we're having some errors. So right now the number of errors they are 6. So let's go up and see the errors that we're having. They say that story 4, story 4, story 4. All of them are from story 4, and they say that slab 4 that slab 6, that's slab number 6, slab number 10, and slab number 16, slab number 17, that they have a very small area. Yeah, that I should shake the slab geometry. So let me just click on close and let's come over to story 4. Yeah, let's come over to story 4. So coming over to story 4, you see that it's all this slab, like this our parapet slab, that they are telling us that we have a very small area. So in this case, we cannot do anything to this error. So that means we are going to leave it like this. Yeah, they said that this is a very small area. Yes, it's true, this is a very small area, but we cannot do anything to this area. So we are going to leave this error like that and continue on with our analysis in our next video. So coming over to this story now, look at, if you see this beam wrapper is inside this beam, but I would like it to be outside. Yes, I would like it to be outside. And also this column dimension, this C1 225 by 225, I would like to be having just something like C1 and not really 225 by 225. Or okay, in which I can leave this one, but this being label, I would like to bring it out. So I'll come over to my setting, Once I'm in my setting, let's allow it to open. Then I'll come over to label. Then once I come over to label, this is the bin label. So I'll take it outside. Look at it, it's not outside. Then in that one, if you want to hide that column section 225 by 225, you click on hide. But let's just leave it because I know some of our column at the ground floor might fail. So some of them might fail. We'll increase their size because I already know, because this is a 3-story residential building, and two, I spaced them well. I spaced my column well. So I know that some of them will require higher sizing, that's higher dimension. So that's why I'll still leave it. So I'll be seeing that. So I'll know what I'm doing. So I'll click on OK. So look at it, it's not outside. So once I'm through with this thing now, next thing I'll be doing is I'll arrange my beam serially. For example, look at, I'm having beam 1, this one should be 2, 3, 4, but look at it, I'm having 7. Look at it, 7, 7, 8, and the 9. So I should arrange my beam serially so that once it comes to detailing, I will not waste time in detailing. So to arrange your beam serially, I'll come over to review, come to relabel, come to relabel members. I'll come over to relabel members. Then I'll click on, since I've done for axis before, I'll click on story, just click on everything. I'll just click on everything and then come and click on OK. So you see that everything will automatically be relabel. So look at it, 2, 3, 4, 5. If you come down, 5. Okay, 5. Maybe 5. Okay, 5. Then you come to this one, 6, 7. Then like that, 8, 9. So like that. Then what? You label your axis. Then next thing, once it comes to analysis, we will now add our wind load. Don't forget, you can still get the CAD file of this architectural plan and practice on your own, so you get to learn everything and it will become part of you the more you practice. And if you found this video helpful, please like the video. Also, you can share it in your class group or in your work group so that more people get to see and more people will learn alongside you.